For quite a while, people have envisioned what it would be like to live in another universe. Thanks to the James Webb Space Telescope, the most shocking telescope in history, the answer to that question can eventually be investigated. While observing the nearest star system to us, Proxima Centauri, which is just 4.2 light-years away, researchers have observed some extraordinary eccentricities originating from one planet in the system, Proxima B. These artificial lights and eccentricities have puzzled the most brilliant minds in the field of science. At any rate, what are these lights? Do they suggest the presence of intelligent life? Join us as we examine the James Webb Space Telescope's unsettling discovery of city lights that could change everything. The only life that we are currently aware of has existed on Earth. Since humankind began civilization, people have wondered whether there is life elsewhere in the universe. To answer such an interstellar question, American cosmologist Jill Thomas Pearson and Terra started the search for extraterrestrial life. The 1984 SETI, Search for Extraterrestrial Intelligence, project's primary goal was to gather spaceborne radio waves. Since radio signals travel farther, they are more likely to be picked up by the 42 telescopes that make up the extraordinary array of Allen telescopes in the mountains of California. However, no notable extraterrestrial signals had been found. Following that, the successful launch of the James Webb Space Telescope helped the effort to examine a range of invisible planets orbiting distant stars. As the planet's largest telescope, drifting about 1 million miles from Earth and equipped with highly sensitive detectors, it may be able to uncover massive revelations. A few decades ago, there were no known planets outside our solar system. However, since then, more than 4,000 exoplanets have been discovered orbiting different stars. NASA suggests that the universe could contain trillions of extrasolar planets. The earliest indications of something happening far beyond our solar system could be found in extraterrestrial vegetation. The Galileo spacecraft, on its way to Jupiter, turned its instruments back toward Earth and saw a clear sign of the presence of plants. It recognized the vegetation red edge, a biosignature, a combination of infrared and red light reflected by plants. For example, a planet like Earth, covered in wild vegetation, should have clearly defined strong signals that are easily recognizable. The JWST will measure the vegetation red edge of faraway Earth-like planets in the inhabited region around stars. This could provide critical indications of something occurring in the exoplanet's atmosphere. When light crosses a planet-star boundary, the JWST may be able to detect it as it enters the planet's atmosphere. The missing frequencies would then be detected by spectroscopy, as airborne particles and molecules absorb particular frequencies, creating a characteristic fingerprint that the JWST can recognize. This method could be used to determine the composition of the atmosphere and whether life is possible. Life could exist on Earth-sized planets with atmospheres like our own, characterized by a mix of oxygen, nitrogen, and carbon dioxide. By searching for elements that aren't typically present, one might even identify intelligent life. For example, chlorofluorocarbons, CFCs, designed for use in refrigeration and cleaning products, would almost certainly be identifiable by extraterrestrials studying Earth's atmosphere from a distant location. If the JWST discovers CFCs in a planet's atmosphere, it could indicate the existence of intelligent life. Despite this, the existence of exoplanets likely won't resemble life on Earth in any capacity. In some cases, even typical living organisms, like extremophiles, could survive in conditions where other living things would perish. These species, mostly microorganisms, can survive extreme conditions such as temperatures up to 250 degrees Fahrenheit or strong acid with pH levels below 3. Since planets are more likely to support life if they don't experience high temperatures or acidic environments, it may be prudent to start with those first. Prime candidates could have temperatures that allow liquid water to exist on their surfaces and revolve around a steady star. Our Sun is a yellow G-type star. These stars are rarer and usually have shorter lifespans. However, in our galaxy, the chances of finding planets orbiting red dwarf stars, more prevalent, cooler, and dimmer than our Sun, are higher. This long lifespan allows for the development of life and the evolution of complex organisms. About 40 light-years from Earth, the TRAPPIST-1 planetary system will be the subject of JWST's first mission. It revolves around a still-active red dwarf star with 7 Earth-sized rocky planets. 3 of these rocky planets, situated in the so-called habitable zone, could have liquid water on their surfaces. Despite the fact that it is smaller and colder compared to our Sun, the TRAPPIST-1 star emits light similar to Earth's Sun, which is sufficient for the close orbit of its planets. This provides the best opportunity to observe city lights outside our nearby planetary system. Proxima Centauri, a red dwarf star that is 4.25 light-years from the Sun, is generally fainter than the Sun. A planet would need to be much closer to it than Earth is to the Sun to support life based on liquid water. In August 2016, astronomers discovered a planet with 1.3 Earth masses in this habitable zone, a Goldilocks-like zone where the light intensity is perfect for liquid water. Proxima B orbits Proxima Centauri, but the fact that Proxima B is tidally locked makes it a potentially airless, dead planet. Since it orbits its red dwarf star just 4.6 million miles away, this close orbit exposes it to strong solar winds that can strip away its atmosphere. However, Proxima B receives sufficient light for temperatures and liquid water to exist. Due to its close proximity to its star, it is believed that Proxima B is tidally locked, meaning it always shows the same side to the star, much like the Moon does in relation to Earth. Proxima Centauri is about 18% the mass of the Sun and emits significantly less energy than one might expect for a planet so close to its star, only about 5% of the Sun's power. This would seem like a desolate wasteland, but liquid water could exist on Proxima B if the planet's atmosphere holds heat. Since the total energy arriving from the Sun is only 65% of what Earth receives, it's still possible that conditions could support some form of life. If Proxima B has an atmosphere dense enough to distribute heat, the side facing the star could maintain temperatures suitable for liquid water, while the dark side might be colder but still habitable in some regions. Scientists speculate that if an atmosphere exists, it could create a habitable twilight zone, a region between the hot, illuminated side and the cold, dark side, where temperatures could be just right for life. The James Webb Space Telescope has been tasked with analyzing Proxima B's atmosphere using its advanced spectroscopic instruments. If the telescope detects gases such as oxygen, methane, or carbon dioxide in the right proportions, it could suggest biological activity. More intriguingly, if JWST identifies artificial pollutants like CFCs, it could be strong evidence of technological civilization. Beyond Proxima B, astronomers are also interested in Proxima Centauri's other potential planets, including Proxima C, a super-Earth or mini-Neptune that orbits farther from the star. If Proxima C has a thick atmosphere with greenhouse effects, it could also support liquid water despite its greater distance. However, Proxima Centauri is known for producing intense solar flares, which could pose a challenge to life on any orbiting planets. These flares release high-energy radiation that might strip away atmospheres and damage potential biological organisms. Yet, some scientists argue that life, if it exists, could have adapted by evolving underground or beneath thick ice layers, similar to extremophiles on Earth. The detection of artificial lights on Proxima B is one of the most controversial claims in recent astronomical studies. Some researchers have suggested that unusual brightness variations observed from the planet could be the result of sitta-like illumination on its surface. If true, this would be the most groundbreaking discovery in human history, a sign of intelligent extraterrestrial life. However, skeptics argue that these observations could be explained by natural processes, such as volcanic activity, reflective surface materials, or even unusual atmospheric phenomena. To resolve this mystery, JWST will continue observing Proxima B in multiple wavelengths of light, searching for patterns consistent with artificial illumination. If the fluctuations in brightness repeat at regular intervals, particularly during the planet's night cycle, it could strengthen the case for an artificial source. Meanwhile, future telescopes, such as the planned Habitable Worlds Observatory and the upcoming Extremely Large Telescope, ELT, will provide even more detailed observations. These instruments could directly image exoplanets and analyze their atmospheres with unprecedented precision, potentially confirming, or debunking, the existence of extraterrestrial civilizations. As humanity stands on the brink of one of the greatest discoveries of all time, the question remains, are we alone in the universe? The James Webb Space Telescope, along with upcoming missions, may soon provide the answers we have long sought. For now, we continue to scan the cosmos, watching and waiting for the faintest glimmer of life beyond our own world. Earth receives. The planet is not particularly favorable for life. It is likely tidally locked, meaning it always faces the same side toward the star, creating a permanently hot side and a cold, dark side with extreme temperature variations. The planet also receives about 5 times the high-energy radiation that Earth does, including X-rays and ultraviolet light, due to its proximity to Proxima Centauri. Proxima B is also bombarded with high-energy particles during stellar flares. Unless it has a protective magnetic field like Earth's, conditions may not be suitable for life. Despite these harsh conditions, Proxima B may still be a more habitable world. Unfortunately, models suggest that the atmospheres of tidally locked planets may be susceptible to rapid erosion because of the freezing out of volatile gases on the night side. Earth's atmosphere can be replenished by volcanic activity, and for planets with strong magnetic fields, their atmospheres are less likely to escape. Since we know nothing about Proxima B's volcanic activity or magnetic field strength, we cannot even speculate whether the planet has an atmosphere. Nevertheless, because an atmosphere suggests the possibility of life, we are eager to learn if Proxima B has one. It could have solar panels on the day side to generate power to light and heat the night side, which would otherwise be too cold and dark for habitation. The discovery of Proxima B has sparked a race to determine if it crosses its star's face as seen from Earth. Researchers would be able to use transits to determine the planet's size and mass, which would assist them in determining its density and confirming its rocky composition. This would provide material-specific information used to form those rocks. During a transit, starlight passing through the planet's atmosphere could reveal its nature. However, the chance that the orbit will be aligned perfectly so that researchers can observe a transit is only 1.5%. The star's tendency to erupt further complicates matters. Astronomer David Kipping of Columbia University says the star is unstable. Stellar heat causes a planet with rocks to absorb light and re-emit it as infrared light. Moreover, rocky planets produce a specific type of infrared radiation from stars like Proxima Centauri. The James Webb Space Telescope, JWST, was specifically designed to detect infrared light, making Proxima B's infrared signature crucial for detecting the planet's atmosphere. Additionally, the JWST's infrared capabilities, which surpass those of the Hubble Space Telescope, could allow it to detect city lights on the planet's night side, even if they are as weak as those currently used on Earth. The JWST could detect artificial illumination, provided it is confined to a frequency band much smaller than the star's light. Proxima B's day side might have extensive solar panel coverage, reflecting starlight. As Proxima B orbits its star continuously, different sides experience extreme temperature variations. The temperature difference between day and night depends on whether the planet is made entirely of bare rock or if air and water circulate heat. If there is no atmosphere, Proxima B's day side and night side temperatures will vary significantly. The day side would release all the energy it receives from Proxima Centauri as infrared light, while the night side would resemble a frozen wasteland. If the temperature difference between day and night is less pronounced, it could indicate an atmosphere. Future space exploration and the search for life beyond Earth hold enormous potential. The James Webb Space Telescope, JWST, may be the key to finding extraterrestrial life in the universe. As the JWST searches for exoplanets, it will ultimately shed light on the possibility of city lights far beyond the stars. As we continue to explore the cosmos, it's crucial to consider the limitations of our current technology. While the JWST is an incredible advancement, it is still only the beginning of our journey into deep space exploration. There are many challenges ahead in the search for atmospheric life on other planets. Conditions, stellar activity, and vast distances mean we may not always receive clear or definitive signals from faraway planets. However, the potential for discovery remains vast, especially as we develop new technologies and improve our approaches to exploring distant worlds. The exploration of Proxima B and other exoplanets continues to push the boundaries of our understanding. Each new discovery, whether it's a planet with signs of water, a potentially habitable atmosphere, or even hints of artificial light, brings us one step closer to answering the profound question of whether life exists beyond Earth. With the capabilities of the James Webb Space Telescope, we may soon be able to see far beyond the confines of our solar system, seeking evidence of life and perhaps even civilization among the distant stars. In the coming years, as the JWST continues its mission, we will gain more insight into the atmosphere and composition of planets like Proxima B. The telescope's ability to detect infrared signatures, along with its unprecedented sensitivity to faint signals, could help us uncover not just the presence of water or an atmosphere but also signs of life, whether microbial or intelligent. It's a thrilling time for space exploration, and the potential for new discoveries is almost limitless. The future of exoplanet exploration. As scientists continue to investigate Proxima B, new technologies and telescopes will play a crucial role in determining whether the planet could support life. While the James Webb Space Telescope, JWST, is a significant step forward, future missions, such as the Extremely Large Telescope, ELT, and the proposed LUVOIR, Large Ultraviolet Optical Infrared Surveyor, telescope, could provide even more detailed observations. One of the key challenges in studying Proxima B is its proximity to an active star. Proxima Centauri emits frequent stellar flares, which could strip away any atmosphere the planet might have. However, if Proxima B possesses a strong magnetic field, it could shield itself from high-energy radiation in a manner similar to Earth. Detecting such a field will be essential in assessing the planet's habitability. Additionally, future missions may deploy space-based interferometers, high-resolution telescopes capable of directly imaging distant exoplanets. By analyzing light reflected from Proxima B's surface, scientists could determine if the planet has oceans, continents, or even artificial structures indicative of intelligent life. The search for biosignatures and technosignatures. A major goal of exoplanet research is to detect biosignatures, chemical indicators of life, such as oxygen, methane, or water vapor. If Proxima B has an atmosphere, spectroscopy using the JWST or future observatories might reveal whether these gases are present in proportions suggestive of biological activity. Beyond biosignatures, astronomers are also searching for technosignatures, evidence of advanced civilizations. The presence of artificial lights on the planet's night side, industrial pollutants in the atmosphere, or radio signals could suggest intelligent life. While no definitive evidence of extraterrestrial intelligence has been found, ongoing projects like Breakthrough Listen are scanning exoplanets, including Proxima B, for unusual signals. The possibility of future human exploration. Although Proxima B is located 4.24 light-years away, a vast distance by current space travel standards, some scientists and visionaries are already considering the possibility of sending robotic probes or even human explorers in the distant future. The Breakthrough Starshot initiative aims to send light sail-powered nanoprobes to the Alpha Centauri system at 20% the speed of light, reaching Proxima B in approximately 20 years. If these probes successfully reach Proxima B and send back data, humanity will receive its first close-up look at a potentially habitable exoplanet. This mission could serve as a stepping stone for more advanced interstellar travel, bringing us closer to the dream of exploring worlds beyond our solar system. Implications for the search for life in the universe. The discovery of Proxima B has profound implications for astrobiology. If life, or conditions favorable for life, exists on a planet orbiting the closest star to our Sun, then life might be far more common in the universe than previously thought. Furthermore, Proxima B is just one of thousands of exoplanets that have been discovered so far. With next-generation telescopes coming online, we may soon find many more planets in the habitable zone of their stars, some of which may be even more Earth-like than Proxima B. A new era of space exploration. As humanity advances technologically, the dream of becoming an interstellar civilization moves closer to reality. The search for life on Proxima B and beyond is not just about finding aliens, it's about understanding our place in the cosmos. Are we alone, or is life a fundamental feature of the universe? Regardless of the answer, the search for extraterrestrial life represents one of the most exciting scientific endeavors of our time. With each new discovery, we take another step toward unraveling the mysteries of the universe and, perhaps, one day setting foot on another world.